terminology, one of the most important concepts in data structures. We will cover the basics like node, root, leaf, and even create a simple tree using Java code. Let's get started. So, what is a tree? In computer science, a tree is a nonlinear hierarchical data structure. Each element is called a node, and nodes are connected by edges. You can think of it like a family tree, or a folder structure in your computer, or even a chatbot decision tree. For example, in Windows Explorer, the Documents folder is the root, and inside it are other folders and files are children. Let's start with the fundamentals. A node. A node is a single element in a tree. Root. The root is the topmost node. It's where the tree starts. Edges. And an edges is a line that connects a parent node to a child. Example: in a university structure, university is the root. Facilities are nodes connected to it, and each connection is an edge. I think you got the idea of these terms, right? So, next, parent. If a node connects to another node below it, it becomes a parent, and the one below is its child. Siblings are nodes that shares the same parent. For example, in a family tree, the parent is mother. Her children are Alex and Emma. And Alex and Emma are siblings. You got it, right? Next, move to ancestors and descendants. A node's ancestors include its parent, grandparent, all the way up to the root. Descendants are its children, grandchildren, and so on. Think of your great-grandfather as your ancestor. You and your future children are his descendants. Leaf and internal nodes. A leaf node has no children. It's the endpoint of a path. An internal node has at least one child. Example, in a decision tree for a quiz, each final answer is a leaf. The questions you ask along the way are internal nodes. Degree of a node and degree of a tree. The degree of a node is the number of children it has. The degree of a tree is the highest node degree in the whole tree. For example, if one node has 3 children and all others have 1 or 2, the tree's degree is 3. Let's go over some key matrices. A path is the way you move from one node to another. Length is the number of edges in that path. Height of a node is the distance the deepest leaf. Depth is the distance from the root to that node. Level is the depth but starts counting from 0. Example, if you go from root, it means level 0, to a node 3 layers down, the depth is 3. If that node has a leaf 2 levels below, its height is 2. Forest. A forest is a group of trees. If you remove the root from a tree, the remaining part parts which are disconnected form a forest. Example, think of multiple files explorers open at once. Each one represents a separate tree in a forest. So, here's the simple Java class to represent a tree node. We store some data and keep references to the left and right children. This is perfect for creating binary trees. Done. Let's now look at a Java program that demonstrates everything we learned about trees. We will create a simple tree, display it, and analyze things like height, depth, leaves, and ancestors. So, we define a static inner class called treeNode. Each node has an integer value and two child pointers, left and right. We use a constructor to initialize the value when a node is created. Preorder method. This method prints the tree in preorder traversal, root, left, right. It helps us verify the structure of the tree step by step. Next, height method. The height method finds how tall the tree is. In other words, the longest path from the root down to a leaf node. Print leaves. This method finds and prints all the leaf nodes. Nodes that have no children at all. Print internal. This prints all the internal nodes which are nodes that have at least one child. Next method, find depth. This method finds the depth of a specific node, that is, how far it is from the root. We pass the root, the target node value, and a starting depth of 0. Next, print ancestors method. This is a recursive method that prints all ancestors of a given node, starting from the parent, grandparent up to the root. Print descendants. This one prints all descendants of a given node, basically the sub-tree rooted at that node. Print tree method. Now this is a cool part. This method visually prints the structure of the tree using characters and for a clear hierarchy. It makes it easy to visualize the tree in the console. Main method. Now in the main method we create a small binary tree manually. Node 1 is the root. 2, 3 are its children. 4 and 5 are children of node 2. We then call all the method to analyze this tree. So the program prints the visual structure of the tree, the preorder traversal, the height of the tree, all leaf nodes, all internal nodes, the depth of a specific node, the ancestors of that node, and its descendants. So, this one file gives you a full understanding of tree terminology in action. Alright, so to wrap up things up, today we covered a bunch of important tree terminology that's super useful when you are learning data structures. We started off by understanding what a node is, when talked about edges that connect nodes, and the special node called the root where everything begins. We also look at leaves, the nodes that don't have any children, and discuss concepts like the height and depth of a tree, which help us understand how big or deep a tree is. Plus, we touch on different types of trees and how they are structured. On top of all that, we walk through a simple Java code example to see how these terms fit together in a real program. These kinds of hands-off example make it easier to visualize what's going on inside instead of just memorizing definitions. Trees might look confusing at first, but once you get comfortable with the terminology and see how code works, you will realize they are actually pretty logical and super useful in lots of programming tasks like organizing data, searching quickly, or even building things like File Explorer. If any part of this felt tricky, or if you want me to dive into more advanced tree topics like binary search trees, AVL trees, or tree traversal in detail, just let me know down in the comment. I am here to help you get confident with these concepts. Thanks so much for watching and hanging out till the end. If you enjoyed this video or learned something new, please give it a thumbs up and don't forget to subscribe so you won't miss out on future coding tutorials. See you next video. Bye bye.